بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is Math 111, Term 222, final exam. Let us see the final and solve it together. First question, we have given a graph of a function, and we need to find the limit of the function when x approaches 0 from the right. So this is 0, and x is approaching 0 from the right. The function is going where? To -1. X approaching 2. Well, if I approach 2 from the right, the graph goes up to infinity. If I approach 2 from the left, the graph goes up to infinity. So the limit is infinity. What is the limit of f of x when x approaches infinity? X approaches infinity, so I'm going in this direction. The graph is going like this. It's approaching 0, approaching y equals 0. Find the numbers at which the function f is not continuous. Okay, it's not continuous here at -2. It's also not continuous at 0. This is discontinuity. It's not continuous at 1. There is a hole here. And it's not continuous at 2 also. It's not continuous here. So -2, 0, 1, and 2. Find the vertical asymptotes, if any. Well, this line is a vertical asymptote, and it has the equation x equals to 2, because it is a vertical line. Find the horizontal asymptotes, if any. Well, the graph here is approaching the line y equals to 0. So the line y equals to 0 is a horizontal asymptote. On the interval 1 to 1, 2, indicate whether the function is concave up. Concave up means the graph is like this. Concave down means the graph is like this. So from 1 to 2, you can see from 1 to 2, the graph has this shape. So it's concave up. On the interval from 2 to infinity, indicate whether the function is increasing or decreasing. Increasing means going like this, decreasing going like this. From 2 to infinity, the function, this is 2 to infinity, the function is coming down, so it is decreasing. Find the numbers where the function f is not differentiable. The function is not differentiable if it is not continuous. So it's not continuous at -2, 0, 1, and 2. It's not differentiable there. Find the value of f of 1. Well, this is 1. F of 1, there is a hole. So there is no f of 1. Also, for differentiability, the function is not differentiable if you have a corner or a vertical tangent, but there is no corners here, no vertical tangents. So the answer here is correct. And here, f of 1 is not defined or does not exist, or whatever you want to say. Find the equation of the tangent line to the curve at the point 0, 0. The equation of the tangent line is equation of a line y minus y0 equals the slope. The slope here is y prime or f prime, the derivative. The slope is the derivative at the point, the value of x. Well, here x is 0, y is 0, so the slope is y prime at 0, x minus the point 0, here also y minus 0, because x is 0 and y is 0. So x0 is 0 and y0 is 0. So the equation y equals y prime at 0 times x. So we need to find y prime at 0. So y prime would be, this is y, x squared plus 3 times tan x. This is a product of two functions. So to find y prime, we need to use the product rule. Derivative of x squared plus 3 is 2x times tan x plus x squared plus 3 times the derivative of tan. Derivative of tan is secant square x. So this is the product rule. Whenever you have f times g and you want to find the derivative, you find the derivative of f times g plus f times the derivative of g. And now let us find y prime at 0. Well, if x is 0, this will be cancelled, so I have 0 here. And if x is 0 here, I'll have 3. So 3 times secant square at 0. Well, cosine 0 is 1, so secant 0 is 1. So the answer is, in fact, 3. So the equation is y equals 3x. This is the equation of the tangent line. Find the absolute maximum and absolute minimum value of the function f on this interval. There is a procedure to find the absolute maximum and absolute minimum. We need to find the critical numbers inside this interval first. So let us find the derivative. To find the critical numbers, we need to find the derivative. And the derivative is 3x squared minus 2 times 6, 12x, and derivative of 5 is 0. And then we need to find the zeros of the derivative, critical numbers. We can solve this equation by a calculator, if you like, mod 5, 3. Or you can take 3x as a common factor. So I'll have x minus 4 equals to 0. So I have two critical numbers, either x is 0 or x is 4. Well, 0 belongs to the interval, but 4 does not belong to the interval. Okay? So in my table, I will consider -3, the endpoint, and 0, which is the critical number in the interval, and 1, the other endpoint. I'm not going to consider 4 because it is not in the interval. Okay. Now I will replace x by 0 here in the definition of f of x. If I put x 0, I get 5. If I put x1, 1 minus 6, -5 plus 5, that's 0. And if I replace x by -3, I can use the calculator and find the answer. -27, -3 to the power 3 is -27, minus 6 times 9 plus 5. The answer is -76. Okay. Let me check. -27, yes, minus 6 times 9 plus 5. So what is the absolute maximum? The smallest is -76. So absolute maximum, the largest is 5. It's 5 at x equals 0, and the absolute minimum is -76 at x equals -3. So that's the answer. Or you can say f of -3 equals -76, f of 0 equals 5. Verify the function that the function satisfies the hypothesis of Rolle's theorem on this interval. Okay, Rolle's theorem has three conditions, three hypotheses. It says that the function has to be continuous on the interval. And of course, this is correct because the domain of f here are real numbers, because the function is a polynomial. Also, we need to check that f prime exists. So f is differentiable, f prime exists on the interval from -1 to 3 open. Because f prime, if you find f prime, it's 4x minus 4, and the domain of f prime is also all real numbers. So f is differentiable from -1 to 3. And also we have to check that f of -1 is equal to f of 3. So if you replace x by -1, I'll have 2 minus 4 times, that's +1 plus 5, so that's 11. And f of 3 would be 18 minus 12 plus 5, and that's also 11. So f of -1 equals to f of 3. So this is the third condition. So now by Rolle's theorem, okay, there exists C, number C, in the interval -1 to 3, such that f prime of C is equal to 0. Well, this is f prime of x. So f prime of C would be 4c minus 4. We replace x by c. This should be equal to 0. So 4c would be equal to 4 if you take 4 to the other side. And then dividing by 4c would be 1. And you can see that 1 is really in the interval from -1 to 3. Find the derivative f prime of the following functions. Well, I have a quotient here, so I should use the formula. The formula says f over g, the derivative of quotient, g squared here, and here f prime times g minus f times g prime. So this is g prime. F prime of x would be the denominator sine x plus 8, square it. And then this 8 is not inside the sign, because if it is inside the sign, he should put parentheses here. Now the derivative of the numerator, 3 times 3 is 9x squared plus 5. That's the derivative of the numerator times the denominator minus the numerator as it is, 3x cubed plus 5, times the derivative of the denominator. Derivative of 8 is 0, derivative of sine x is cosine x. So this is the derivative of this function. This is the first part. Second part, I have, I should use this rule. The derivative, we know that the derivative of x to the power n is nx to the power n minus 1. But using chain rule, derivative of u to the power n would be n times u to the power n minus 1 times u prime. So here, f chain rule, you should use here. F prime of x would be 16, okay, times 2x to the power 7 plus sinh x to the power 15, we subtract 1, 16, then times the derivative of what is inside. So derivative of 2x to the power 7 is 14x to the power 6, plus derivative of sinh, which is cosh x. So that's the answer. Okay. Derivative of ln is 1 over 2x cubed minus 3x plus 5. Okay. Derivative of ln x is 1 over x, but derivative of ln u would be 1 over u times u prime. So derivative of this is 6x to the power 2, derivative of 2x cubed minus 3. This is the derivative of the first term. Derivative of the second term, the 7 is just a constant. Derivative of sine inverse x is 1 over square root of 1 minus x squared. So that's the answer. Derivative of e to the power u using chain rule is e to the power u times derivative of u. So derivative of x to the power 5 is 5 times x to the power 4. Derivative of cosine is negative sine x. Using implicit differentiation, find dy by dx or y prime. Okay, so I'll find the derivative with respect to x of this equation. Here in the left-hand side, I have a product of two functions. So I'll use the product rule. Derivative of sine x is cosine x times cosine y, then plus sine x as it is. Derivative of cosine y is negative sine y times y prime, okay, equals derivative of x squared is 2x, derivative of negative 5y is negative 5 times y prime. Okay, whenever you find the derivative of y, you multiply by y prime. And now we need to solve the equation for y prime. So I'll keep this term here, negative sine x sine y times y prime, and I'll bring the 5y prime here to this side, and I'll take this term cosine x cosine y to the right-hand side. And now I take y prime as a common factor. I can write 5 first, minus sine x sine y equals 2x minus cosine x cosine y. And then I divide by the coefficient of y prime. So this would be the final answer. This is y prime. Find the following limits if it exists. Well, we will use L'Hopital rules. So let us replace x by infinity. I'll have infinity squared, that's infinity, times e to the power negative infinity, and that's 0. Infinity times 0, one of the indeterminate forms. So I have to write it, bring one of the functions down. Well, e to the power negative x, I can just bring it down and write it e to the power x. And now when I replace x by infinity again, I'll have infinity over e to the power infinity, which is infinity. So I can use now L'Hopital's rule and find the derivative of x squared, and that's 2x. And now replacing x by infinity, I still have infinity over infinity, so I use L'Hopital rules again. Derivative of 2x is 2, derivative of ex is ex. And now e to the power infinity is infinity, and 2 to the power infinity is 0. So the limit is 0. If I replace x by 0 here, 1 minus 0 would be 1. 1 over 0 is infinity, so I'll have 1 to the power infinity. Well, to find the limit, I call y 1 minus 2x to the power 1 over x. I call it y. And then I apply ln to both sides. This method is used to bring 1 over x down, because we know that one of the properties of logarithmic functions, if you have ln b to the power r, this would be r times len b. So I can bring 1 over x here. And now I find the limit of len y. The limit when x approaches 0 from the right of len y. And this would be the limit when x approaches 0 of len 1 minus 2x over x. I can write this as len over x. If I replace x by 0, I'll have len 1, which is 0 over 0. So I can use L'Hopital's rule. Derivative of x is 1. Derivative of len is 1 over 1 minus 2x times negative 2. So over 1, so there is no need to write over 1. Now, if you replace x by 0, I'll get negative 2 over 1, that's negative 2. So the limit of len y is negative 2. If len y goes to negative 2, then you can raise both sides to the base e, and we get that the limit of y when x approaches 0 is e to the power negative 2. So the answer here is e to the power negative 2. That's the answer. Well, if I replace x by 0, I have 0 over 1 minus 1, that's 0. So I can use L'Hopital's rule immediately. Derivative of x squared is 2x. Derivative of 1 is 0. Derivative of cosine is negative sine, so negative cosine would be sine. Well, 0, again sine 0 is 0. So I'll use L'Hopital's rule again. Derivative of 2x is 2. Derivative of sine x is cosine x. Now, cosine 0 is 1, so the answer would be 2. What about here? When x approaches 0, 2 to the power 0 is 1, e to the power 0 is 1, so 1 minus 1 over 0, that's 0 over 0. Since you have 0 over 0, I'll use the L'Hopital's rule. So derivative of 2 to the power x is 2 to the power x times len 2, that's the formula, okay? Minus derivative of ex, that's ex, and derivative of x is 1, so there is no need to write it, okay? So when x approaches 0, I have 2 to the power 0, which is 1 times len 2, minus e to the power 0, which is 1. So the answer is negative 1 plus len 2, that's the limit. Okay, for the function, find the following, the critical numbers. To find the critical numbers, I find the derivative. The derivative is 2 times 3, 6x squared, minus 12 times 2, 24x, plus 18. I put it equals to 0, and I find the zeros of this equation. Well, this is a quadratic equation. You can solve it by the calculator. Also, if you divide by 6, I'll have x squared minus 4x plus 3, and I can factor easily. So x minus 3 times x minus 1 is 0. So x is 3 or x is 1. So the critical numbers are 3 and 1. These are the critical numbers. The intervals on which f is increasing and decreasing. To find these intervals, we need to use the first derivative test. And to use the first derivative test, we need to test the signs of f prime. So this is from negative infinity to infinity. This is the real line. And we put the critical numbers here, and we test the signs, because whenever f prime is positive, then f is increasing. And whenever f prime is negative, then f is decreasing. So where is f prime? This is f prime. F prime is 6x squared minus 24x plus 18. If you take a number less than 1, for example, 0, replace x by 0, you will get plus 18. So f prime here is positive. If you choose 2 and put it here, 6 times 4 minus 24 times 2 plus 18, you will find the sign is negative. If you take a number greater than 3, 4, for example, you will find that the sign is positive. Or there is a formula that says whenever you have second degree equation, between the roots, the sign is opposite to the sign of x squared. So sign of x squared here is 6 positive. So we have negative, positive, positive. Now, if f prime is positive, then f is increasing. Here f is decreasing, and here f is increasing. So f is increasing in or on from where? From negative infinity to 1, union from 3 to infinity. And f is decreasing where? From 1 to 3. Find local maximum and local minimum values of f. Well, here the function is going up, then going down. So we have a local maximum. So local maximum is f of 1. And if you go to f and replace x by 1, I'll have 2 minus 12, that's negative 10, plus 18, and that's 8. So f1 is a local maximum. Here the function is going down, decreasing, then increasing, so I have a local minimum here. So local minimum would be f of 3. And if you go to f and replace x by 3, 2 times 3 to the power 3, that's 27, minus 12 times 3 to the power 2, that's 9, plus 18 times 3, so the answer is 0. Okay, f of 3 is 0. So this is a local minimum. The intervals on which f is concave up, concave down, and inflection points. We find concavity from the second derivative. So the first derivative, that's the first derivative. Let us derive again. So 12x minus 24. And derivative of 18 is 0. So 12x minus 24, that's the second derivative. Now we put it equal to 0, and we find the 0 of f double prime. So 12x would be equal to 24, or x equals 24 over 12. That's 2. So now we do the same and check the signs of f double prime. This is the real line, and we have only 2 here, zeros of f double prime. Whenever f double prime is positive, f would be concave up. And whenever f double prime is negative, f would be concave down. Choose a number less than 2, 0, for example. 0 minus 24, that's negative. The number greater than 2 will make f double prime positive. Or if you have a linear function, then to the right of the 0, the sign is equal to the sign of x. So here 12, so the sign to the right of 2 is positive, to the left of 2 is negative. Here the function is concave down, here the function is concave up. So concave up in the interval from 2 to infinity, concave down in the interval from negative infinity to 2. Inflection points, inflection point, the point where the function changes from concave up to concave down, or from concave down to concave up. So 2 and f of 2. To find f of 2, I go to f and I replace 2 to the power 3, that's 8, negative 12 times 2 to the power 2, that's 4, plus 18 times 2, and the answer is 4. So 2 and 4 is an inflection point. Sketch the graph of f. To sketch the graph of f, the most important thing to me here are the points I got. So the local maximum, 1, 8, 1, 8 is a local maximum. That's very important. So this is 1, okay? 1, 2, 3, 4, 5. 6, 7, 8. So 1 and 8, this point is a local maximum, which means the graph is doing like this. There is a cap. Okay? The other point, the local minimum, well, 3x and y is 0. 3, 0 is a local minimum. This point is also very important to me. This point is 3 and 0. There is a minimum here. So the graph makes like this, like a cup. Okay. And then the other point important, the inflection point, 2, 4. So 2 and 4 here, this point is an inflection point. Inflection point means the graph changes concavity. So I know that the graph would go like this. It's concave up here, but starting from here, it would concave down. Okay, so from here, it would concave down like this, and it will go down. Here it will go up. So here it will continue up. Okay, here the concavity is down, it will go down. So let me check the y-intercept. It will intersect with y-axis. So what is the y-intercept? If I put x 0 in f, I get 0. So in fact, the y-intercept is 0. Y-intercept is 0. So the graph passes by 0, 0. Okay, so it goes, the concavity is, excuse my graphing. Oh, it's not easy for me to graph here. I'll try to sketch the graph. Maybe I needed to, okay, shouldn't do like this. The graph should continue. Of course, it should go there. Okay. I can make it larger for the graph to be easier. I can, okay. I can make 1 here, 2 here, and 3 here. So this is 3, 0. This is 2 and 4, and this is 1 and 8. And it passes by 0, 0. And it continues after 0, 0 like this. This will be fine. And then it goes like this up to here. And it starts to be concave up here like this. So this is an accepted graph of the function of x. Find two numbers whose difference is 46 and whose product is a minimum product. Yeah. So two numbers, let me call them x and y. So what do we know? We know that their difference is 46. So x minus y or y minus x is 46. And their product is minimum. So x times y is minimum. Well, the thing we need to minimize or maximize, that would be my function. So my function would be the product. I need to minimize the product. So I'll call the product x, y. And now my function should be function in one variable. So I should replace x by y or y by x. From this equation, if you take x to the other side, then I can write it x is y plus 46. Okay, so I can say that my function is y squared plus 46y. Or you can replace y by x and make it a function of x not in y, in x not in y. Both are correct. So now we need to find the critical numbers. So we find the derivative of b. The derivative of y squared is 2y plus 46. To find the critical number, we put it equal to 0, and we solve the equation. We take 46 to the other side, and then y would be negative 46 over 2. That's negative 23. So the product should be minimum. Okay, so we should have a minimum value, a local minimum at -23. How to find out? Either you find the signs of P prime or you find P double prime. P double prime is just 2. The derivative of 2y is 2. It's greater than 0, so we have local minimum. That's the theorem. Whenever P double prime, the second derivative is positive, we have a local minimum at -23. So now I'm sure that the product is minimum at -23. So y is -23. I can find x minus -23 equals 46. So x is 46 minus 23, that's 23. So the two numbers are -23 and 23. Find the vertical and horizontal asymptotes, if any, of this function. Well, to find the horizontal asymptote, I find the limit when x approaches infinity or negative infinity, positive or negative infinity. Well, whenever, if you take it positive or negative, we will take the highest power up 9x and the highest power down x squared. So we can cancel x with x, and I'll have 9 over x. 9 over infinity or negative infinity will give you 0. So the equation of the horizontal asymptote y equals to 0. To find the equation of the vertical asymptote, I need to factor the denominator to find the zeros of the denominator, because the zeros of the denominator will give you the equations of the vertical asymptote whenever you have a rational function like this. So you will have x minus 3 times x plus 1, okay? Because -3 plus 1 is -2. So the equations of the vertical asymptotes, there are two vertical asymptotes, either x equals to 3 or x equals to -1. If you want to make sure that we have vertical asymptotes there, if you find the limit when x approaches 3 from the right or from the left to this function, you should find that the limit is infinity. Okay? That's the definition of the vertical asymptote. So if you replace x by 3, you will have here 9 minus 6, you will have 0. Okay, so you will have over 0. But here you will have 18 plus 2, 20 over 0. Okay, so this will give you positive or negative infinity. To find out whether it's positive or negative infinity, you replace x by 3.1, for example. So 3.1 squared minus 2 times 3.1 minus 3 will give you a positive sign, and up positive, so the limit would be infinity. This is just to check, okay? And you can find the limit when x approaches 3 from the left. It would be also positive or negative infinity, and also for x equals -1. But for the question, it's enough to write this equation and this equation. That's enough to get the mark. Oh, that's the end of the exam. Thank you very much. I hope you enjoyed it, and I hope you will do well in your exam this semester.